Hi everyone, you are welcome back to the engineering materials part 2. So at the part 1 we introduce us to the engineering materials and let you know that at the end of this study session you should be able to describe engineering materials, identify different type of engineering materials and understand the application of different engineering materials. So at the part 1 as well, we introduce you to engineering material in terms of religion and historical background. And having done that, I go around, I introduce you to the total engineering material cycle, how the raw are extracted from the hard crust. Everything moved down to where we are using it at home, at lab, at everywhere, and back to the hard crust. And also we classify engineering material, let you know that material are classified according to the engineering field. Material are classified according to their types and composition. And now let us discuss about at the part 1 we discuss about the description of metals, and where I let you know that metals are of two types, ferrous metal and non-ferrous metal. So now let us proceed to description of and sources of polymer. So polymers are not engineering materials. And the polymers are of two types. We have natural polymer and synthetic polymer. So the natural polymer occur are those derived from plant and animal, such as rubber or skin. They are natural polymer. And whereby the synthetic polymer are derived from small organic molecules. So majority of plastic, rubber, and fiber materials we use at home, offices, laboratory are synthetic polymers. Uses of polymers. Look at the diagram very well. Example of natural polymers. All the polymer here, they are natural, whereby all the one here, they are synthetic polymers. So example of the natural polymer are DNA, they are rubber, they are cellulose, they are wool. And whereby the synthetic are nylon, polyester, Teflon, and epoxy materials. All these, they are polymers, and these are their uses according to the diagram you see. And also, description and sources of another material that are called ceramic. This is another material called ceramic. Ceramic are compound between metallic and non-metallic elements. They are most frequently oxide, nitrides, and carbide. So example of a ceramic, common ceramic include aluminum oxide, silicon dioxide, silicon carbide, and silicon nitride. Additionally, what some refer to as traditional ceramic are those composed of clay materials. That is a polyethylene, as well as cement and glass. They are natural ceramics. Types and uses of ceramics. So ceramic are used for structural clay products like brick, sewer pipe, roofing, and wall tile, flue linings. All these they are structural clay products. We have white wares like dinnerware, floor and wall tiles, electrical porcelains. They are white ware, they are ceramic, which you are using at home. And also, if you check the table, the table of the lab, a chemistry lab, they use a floor tile, a tile to cover their table in order to it has high resistance against chemical. Also, we have refractory ceramic like brick, monolithic products used in metals, glass, cement, ceramic, energy conversion. So all these, they are ceramic products. Likewise, glasses that you are using at your home, even at lab for the experiment, Boyle's law experiment, the gas experiment, and also in the chemistry lab, the glassware are there. So all the glasses of different form you see there, they are referred to as ceramic. And also we have abrasive, natural abrasive, synthetic abrasive. All the form of abrasive They are used for grinding, cutting, polishing, lapping, and others. They are ceramic products. And cement is a ceramic product and also advanced material. So all these, they are the type of ceramic and where they are using them one after the other. So you can see the picture here, your cup at home, which you use to drink or eat food, they are ceramic. This is also ceramic products. This is a roofing, ceramic roofing, and also water is also ceramic. The sink, wash and sink that is available in our workshop is made up of ceramic, and some electrical component as well. They are used as they are like insulators. They are ceramic products. They are poor conductor of electricity. And now another material that we have is hybrid materials. So hybrid material refer to any of class of material in which organic and inorganic components intimately mix in a predetermined configuration and scale. So hybrid material type of them is broadly classified into two. We have natural hybrid material and synthetic hybrid material. So at the beginning of the lecture, I let you know that all living things and non-living things, they are engineering materials. Even we human beings, we are engineering materials. In what way? You can see it under the natural type. Under the natural type of hybrid material are wood. Wood is made up of cellulose fiber and lignin. Likewise, bone, our bone, is made up of hydroxy, apatite, and collagen. Our skin is a natural hybrid material, and leaf from the plant is also a natural hybrid material. So this is a natural. So we human beings as well, we are hybrid material, we are engineering materials. And also synthetic type of hybrid material are fiberglass, Kevlar, cement, concrete. They are hybrid material because they involve two or more material come together to form one material. They are hybrided to be one material. So this is the nature of synthetic hybrid material. So when the metal, polymer, elastomer, glasses, ceramic, they are blended together to form one material, they are now referred to as a hybrid material. They are referred to as what? Hybrid materials. So uses of hybrid material. So hybrid material are used for engineering purposes. So in automobile industry, you can find the application of hybrid material there. So majority of automobile parts, they are made up of hybrid materials. Unlike the olden days where the majority of the parts is made up of the iron only, but this time around, they are made up of hybrid material. They are lighter in weight and tougher. And also, the hybrid material are commonly used in the for medical purposes. That's the biomaterial. So when we get to the next thing, we are going to extensively talk about the biomaterials. So description this another material is a semiconductor. Thank God you are physics students. You are going to make use of a conductor for the practical exercise. So semiconductor are material which have electrical properties that are intermediate between the electrical conductors and insulator. So uses of semiconductor, this is a semiconductor there that you are commonly know in your electrical appliances, electronic appliances, a resistor, capacitor, this is a diode, this is a transistors, this is a IC, that's integrated circuits. And all this one, they are made up of semiconductor for the electronics purposes. So and this the next one is biomaterials. So biomaterial is a compounding word. Bio is a life and material. So the meaning of it is any type of material that's used for the sustenance of life. They are biomaterials. They are material implanted into human body for replacement of disease or damaged body parts. They are simply referred to as life-supporting material. That's the biomaterials. The most important property of biomaterials used for fabricating plants is biocompatibility, followed by corrosion resistance. So if you have opportunity, you go to orthopedic hospital at Bobi Yaba or military hospital beside the Yaba Tech, So the majority of the material they are using for orthopedic purposes, they are referred to as biomaterials. They are referred to as biomaterials. And biomaterials are used for joint replacement, bone plates, intraocular lenses, bone cement, dental implants, blood vessels, prosthesis, heart valve. So example of natural biomaterial are collagen, that's bone and cartilage, fibrin, agarose. So all these one they are natural biomaterials. An example of a synthetic biomaterial are metal-based biomaterials and ceramic-based biomaterials, and likewise polymer-based biomaterials. So the biomaterial is simply referred to as life-supporting materials. Life-supporting materials, and they are of two types: natural biomaterial and artificial biomaterial or synthetic biomaterials. So if you want to study medical physics, this is part of medical physics you are going to know. If you're very good in engineering materials, very sound in biomaterials, definitely you are good to go to fit into medical physics. Perfect. So uses of biomaterials. So based on the history of biomaterial from replacement to regeneration. So at the early stage here, they make use of the either natural or synthetic biomaterial for replacement of body that damaged. At here as well, is a step up where they make use of some natural. Here they make use of synthetic. So at this stage here, final stage here, is referred to as regeneration, whereby they use a cell or cell as well to 3D paint a part of human being for replacement of damaged part. You can see 3D degeneration. So the 3D painting it here, whereby at early stage there's nothing of such, but as a result of improvement in science and technology, advancement, innovations, here they regenerate the human body, human part easily. So these are the uses of biomaterials and their history accordingly. So the next material that we are going to talk about is advanced materials. Advanced materials. So advanced materials are materials that are utilized in high technology, high-tech applications. These materials are typically either traditional materials whose properties have been enhanced or newly developed high-performance materials. So it offers significant potential application in the field of electronics, aerospace, automotive, coating, and so on. So examples of advanced material are electronic equipment, computers, fiber optic system, spacecraft, aircraft, and military rocketry. So all these one they are referred to as advanced materials. So this is the end of part 2 of engineering materials. Let us meet in part 3. Have a nice day.